There it goes. Okay, so if I look at the x minus y and the negative x plus y, they look almost exactly alike. But I have opposite signs. Positive x is negative and negative y is positive. How could I change this to make it look exactly like x minus y? Jonah?
Would you multiply it by -1?
You could multiply it by -1 or think divide out a -1. Either way, it works the same. So I'm going to do that, exactly what Jonah said. The first term's going to stay the same. 3x times quantity x minus y plus, but you could think of multiplying by the -1, which would produce a positive x minus y. Or if you want to think divide out a -1, it would work the same way. Because if I divide out a -1, I get a negative divided by a negative is positive, and y divided by -1 would give you negative y.
Do you do this in the 4?
You need to just multiply the -1 out by the 4. So what this will turn into is 3x times quantity x minus y minus 4 times quantity x minus y. So that's what it'll turn into. Now if you think, how can I do that? How can I divide out a -1? If you're thinking about multiplication, if I have you multiply like 3 times 4 times 5, you can multiply 3 times 4 together and just call it a 12, and then you have that 5 on the outside. It's the same concept. We can multiply two numbers together and just leave it as a factor on the outside. Lily? Yeah. And then what that allows us to do is we can take a look at this x minus y, and now can we factor that out? Yeah, it's a GCF. It's in both terms. So I can just bring it out to the front. What do I do with the 3x and the minus 4? Group them together. And I group them, and I have quantity x minus y times quantity 3x minus 4. All right. Do you need an extra?
No, I said.
Okay. All right, looking at the next one. How would we start that? I see an x plus y, and I see an opposite factor, negative x minus y. So in the same way we did the other one, what would we want to do to start here? What do you guys want to do? How do I get this to match x plus y? Anna?
It would be x. It would be x plus y because you divide by -1.
Good. So let's go ahead and let's do that. Nice. So we take that n times quantity x plus y, and I'm going to factor out a -1, and that will leave me with x plus y. Now that -1 is being multiplied by n minus 1, so I'm going to distribute it into both terms. So that gives me n times quantity x plus y plus negative n plus 1 times quantity x plus y. Finally, what's the last thing that we do? Take out the x plus y, because it's in both terms. So take it out. And that leaves me with quantity x plus y times quantity n plus negative n plus 1. Is that as far as I can go? No, what else can I do?
You can make it 0.
Yeah, I can add up the n plus the negative n to get 0. So I have x plus y multiplied by 0 plus 1, which is 1. Do I even need to put that times 1? No, it just is x plus y. Any questions on that? That's what happens if you have opposite factors. Number 74 in your homework is like these type. So that's why we didn't do it yesterday, but you do have it added to tonight's homework. All right, go ahead, flip it over then. Last thing we look at is how do you factor non-polynomials? So expressions that have fractional exponents. Josh? You need that back page, yeah, because the printer kind of did a weird thing with this, so let me find you that back page. There you go. In order to understand how to factor these expressions with fractional exponents, we're going to think about how we factor normal exponents or exponents with whole values. So let's think about it. Looking at these three terms, how do you know, or what would you factor out of these three terms? X squared. Now when you factor out an x squared, or if you factor out any factor, you're essentially dividing every term by that factor. I keep it out in front. And just to help us visualize what we actually are doing, when you take x to the fourth divided by x squared, what are you doing with the 4 and the 2? Subtracting. So this is actually 3x to the fourth minus 2 plus 2x to the third minus 2 plus 5 times, now you could call that x squared, or to the x to the second minus 2. But even easier to visualize, what is any number divided by itself?
1.
Just 1. The number 1. So I could call this 5 times 1 or just 5. And that's how you know that this simplifies to x squared, 3x times quantity 3x squared plus 2x to the first plus 5. We're going to use that exact same process to factor out the smallest factor in the examples below. For expressions with integer or fractional exponents, we always factor out the smallest power, which is the greatest common factor. So we always factor out the smallest power with the greatest, which is the greatest common factor. Just like looking at up here, we factored out the x squared. That was the smallest power. Looking at example 1, how do we know which one we're going to factor out? Look at x to the negative 1/2 and x to the 1/2. Which is the smallest power? X to the negative 1/2. So let's go ahead and let's make a little note. We know we're going to factor out the x to the negative 1/2. It's the smallest. So when you factor it out, you're essentially dividing it out. So let's just go ahead and let's write what we're doing. We're dividing out the x to the negative 1/2. I'm dividing out to that x to the negative 1/2, and I am putting it out in front because I'm factoring it. So I'm dividing it out to the front. Now what's left in the first part? What's x to the negative 1/2 time, or divided by itself? Just 1. What's 9 times 1? Just 9. So that first term is going to be 9. And then I have plus 2x to the, what do you do if you are dividing two numbers with the same base? What do you do with their exponents? You subtract them. Good. So I know I'm going to take 1/2 and subtract a negative 1/2. Let me zoom in on that a little bit. So 1/2 minus a negative 1/2. Okay, now we simplify this out. So I have x to the negative 1/2 multiplied by, in parentheses, 9 plus 2x raised to the, what's 1/2 minus negative 1/2? Just 1. Because what happens when you minus a negative? Becomes a positive. What's a half plus a half? 1. Or you can think they both have a common denominator, so add the numerators. It becomes 2/2, which is just 1. So now this is factored down, and we can go ahead and box it. All right, let's try example 2. Example 2, what are we going to factor out? What's the smallest power that you see? The negative, what? The negative 2/3, right? So we know we have to factor that out. So I'm going to divide by 3r plus 1 to the negative 2/3. Divide it into everything because I'm factoring it out of every term. And I bring it out in front because I'm factoring it to the front. And now on the inside, I want to be left with positive exponents. Let's see if it worked. What's 3r plus 1 to the negative 2/3 divided by itself? Just 1. So that becomes 1. Plus, I have the same base. I'm dividing. So what do we do with the exponents? Subtract them. So I'm going to take 1/3 minus a negative 2/3. And then the last term, I have plus 3r plus 1 raised to the, again, I'm going to subtract these. So I'm going to do 4/3 minus a negative 2/3. Now we just simplify. So I have 3r plus 1 raised to the negative 2/3 multiplied by 1 plus 3r plus 1 raised to the, okay, what's 1/3 minus a negative 2/3? Just 1. Because think of it as 1/3 plus 2/3, which becomes 3/3, and that's 1. Plus 3r plus 1 raised to the, what's 4/3 minus a negative 2/3?
2.
Yeah, 6/3, which does become 2. So 6 divided by 3 is 2, and I can go ahead and box this. Now, always leave the inside factor with positive exponents. So that's how you know you've done that right. If you end up with positive exponents, leave with positive exponents, then you know you've factored out the smallest factor. We're not done though, so don't just box it yet. Jamie?
Do you leave the terms in parentheses in that order?
No. Good question. We're not going to leave it in this order because we need to put the highest exponent first. And not only are we going to not leave it in this order, but we need to simplify this all out to make sure there's still no common factors left inside. So we need to distribute this, we need to multiply it out. We need to simplify this, kind of what I have in blue, as far as it can go. So let's think about how we would simplify 3r plus 1 squared. How do you simplify that? What process do you have to use to square that? FOIL it. I have to do 3r plus 1 multiplied by itself, which you can see is necessary for foiling. What's 3r times 3r? 9r squared. 3r times 1 is 3r, and if I do the inside, 1 times 3r is 3r. So what is 3r plus 3r? 6r. Last term, what's 1 times 1? 1. Okay, so I'm going to go ahead, I'm going to replace that, and I have this as 1 plus 3r plus 1 plus 9r squared plus 6r plus 1. This is all on the inside, and I still have that GCF of 3r plus 1 to the negative 2/3 on the outside. Now that I've multiplied that out, do you see some like terms that we can combine? Yeah, we have a 3r, we have a 6r, and we have 3 1s. Now before I do that, which term am I going to put first? The 9r squared, because it has the highest exponent on it. Good. So I have 9r squared plus, what's 3r and 6r? 9r. What is 1 plus 1 plus 1? 3. And I still have that GCF on the outside, so I'm going to make sure to copy it down. 3r plus 1 to the negative 2/3. Now look at why it was necessary to simplify that. What do you see that we can still take out?
3.
A 3. There's a common factor of 3 inside every term. So I divide that out. I'm going to divide it to the front. And I have 3 times quantity, 3r plus 1 to the negative 2/3, multiplied by 3r squared plus 3r plus 1. And then that would actually be as far as we can go. Jamie?
So you read the exponent on the outside negative?
And here's kind of a tricky piece. If you are asked to factor then you can leave the exponent on the outside negative, because if we bring it to the denominator, then you're left with a radical in the denominator. Because know how this would turn into the cube root of 2? And essentially we don't want a radical in the denominator here. So if you're factoring, just leave it as what are the factor times the factor times the factor. If you're asked to simplify it, or if I ask you leave no exponents negative, then you know to bring it to the denominator. Okay. It's kind of, I know that's kind of a contradiction, but you just have to think when I'm factoring, I'm just breaking it down as far as it can go. Good question. Any other questions?